Okay, to start out, I noticed that all of the angles in every triangle will add up to 180 degrees, so I might start out by trying to do 3x minus 11 plus 2x plus 11 plus 2y equals 180. But then I noticed that then I would have two different kinds of variables in the same equation, which makes it hard to figure out what they each are. So I'm going to try to do something else to see if I can find an easier way to do it first. So I'll cross this out for now, and I might come back and use it again later if I can't find an easier way. The next thing I'm going to look at, I'm going to notice that this triangle is an isosceles triangle. The tick marks show me that this side here on the left and this side here on the right are both the same length, which means that the two angles, this angle here and this angle here, are the same amount of degrees. So I'm going to try using this equation instead, that 3x minus 11 is equal to 2x plus 11. The first thing I noticed, there's only one variable in this equation, so that looks better. I'm going to take away two x's from both sides, and all that will be left is that x minus 11 is equal to 11. So I think of a number that you subtract 11 and it equals 11, and that number is 22, so x equals 22. Alright, let me see now how big the angles are using that section off. So using 22 in the expression over here, so I'm going to use it in this one right here, I get 3 times 22 minus 11. That would be 66 minus 11, which gives 55. Okay, so that means that this angle up here is 55 degrees. Then I try with the other angle over here, 2x plus 11, and I get 2 times 22 plus 11, and that gives 44 plus 11, which is 55. So this angle is also 55 degrees. Okay, that's a good sign. They're supposed to be equal because of the equal sides, meaning two equal angles also. Now I'm going to use that information to figure out how big the very last angle is, this angle down here. I know that the three angles in a triangle add up to 180, so I'll do 55 plus 55 plus the third angle, 2y, equals 180. I notice that y is the only variable in this equation, so that means I'll be able to easily find out what number y is. I'm going to take away 110 from both sides now, so I get 2y equals 70. It looks like y equals 35. Alright, in this triangle here, I see that it's also an isosceles triangle. The left side is the same length as the right side, which means that this angle here of 3x is the same as this angle of y plus 7. So I'm going to try writing that first. 3x equals y plus 7. Now I have two different variables in the same equation, so that's going to make it hard to figure out what x and y are. So I'm going to cross it out for now. I might come back and use it unless I can find an easier way. Let me look at the triangle again. This angle right here is 90 degrees, so there's a 90-degree angle. And since all three of the angles in a triangle add up to 180, that means that 180 minus 90 is equal to 90. That leaves 90 degrees left over for the other two angles. But since those angles are both the same, that means that those 90 degrees have to be split up evenly between them. And it looks like that means 45 degrees for each of the other angles. 45 degrees there, 45 degrees there. So now I just have to figure out what number x is and what number y is. So I think, okay, 3 times x has to be the same as 45 degrees because I already found out that's a 45-degree angle. So it looks like x equals 15. And then y plus 7 also has to be 45 degrees. So it looks like y is equal to 38. Alright, once again I have an isosceles triangle. This left side is the same length as this right side, which means that this angle right here is the same as this angle here. So this angle in here is also x minus 2, just like the other one. And I remember that the three angles in a triangle will add up to 180, so I'll do x minus 2 plus x minus 2 plus 4x minus 10, whoops, not minus, plus 10. That all adds up to 180 degrees. Looks like altogether I have 6 x's on the left side of my equation, so 6x, and it looks like altogether I have a negative 2, and a positive 10. That altogether is a positive 6, and that all equals 180. And so I get the taking away 6 on both sides. 6x equals 174. So it looks like divide 174 by 6. That goes in twice. 54, and that goes in 9 times. So it looks like x is equal to 29. So that means that this angle right here, x minus 2, would be 29 minus 2. So this is a 27-degree angle right there. And if you'll notice, these two angles right here, the 3y and the 27-degree angle, they form a linear pair. So that means that they add up to 180. So 3y plus 27 adds up to 180. If I take away 27 from both sides, I get that 3y is equal to 153. And then 3 can go in, divides into 153 51 times. So I get that y is equal to 51. Alright, so to start out with, I notice that I have an isosceles triangle right here. Those two sides are the same length. I can tell by the tick marks, which means that this angle right here is the same as that angle right there. So I'll go ahead and write an equation that shows that 5x minus 10 is the same number as 3x plus 10. If I take away 2x's from both sides, 3x's from both sides, then I'll be left with 2x minus 10 is equal to just 10. And then if I add 10 to both sides, then I'll have 20 over here. And when I add 10 to the left side, it cancels out with a negative 10, so I just have 2x's. And then I get that x is equal to 10. Then to find out what y is, this seems like it's going to be a little bit tricky. I'm going to have to see if I can use the fact that x equals 10 to find out some of the angles. So let me first focus on this one. 3 times 10 is 30, plus 10 more is 40. And then this one right up here, 5 times 10 is 50, minus 10 is 40, so that's a good sign that those both are the same. It's an isosceles triangle. They're supposed to be the same. And then that leaves just one angle in that triangle, and to figure out what it is, I'll just do 40 plus 40 to get 80. And since all the angles in a triangle have to add up to 180, that must mean that this one up here is 100 degrees. Now, take a look at these two angles that I just marked in green. They form a linear pair, which means that they both add up to 180 degrees. So that means that since one of them is 100, the other one must be 80. So I'll write 80 in there. Then notice, once again, I actually have two isosceles triangles in this picture. This isosceles triangle over on the left, I'll mark its two sides that are the same length. This side on the left and this side right here on the right, those are the same length, which means that the two angles are the same. So I'll put that 4y is the same as 80. which would mean that y equals 20. Okay, once again I have two isosceles triangles here. I'll focus on the top one first. I have this triangle and this triangle are, that the left side and the right side are the same length, which means that this angle I just pointed to and then this angle over here on the left are both the same. So since the one on the left is 2x plus 11, so is this one. It's also 2x plus 11. Then I'll use the fact that all three of the angles in that triangle add up to 180 degrees. 2x plus 11 plus another 2x plus 11 plus x minus 2. Those all add up to 180 degrees. I will notice that I have 2x's plus 2 more plus another x. That's 5 x's altogether, so 5x. And then I have 11 plus 11 more, that's 22. And then minus 2, that takes me back down to 20, so plus 20. And then that all equals 180. I'll take away 80 on both sides and get that 5x equals, take away 20 on both sides and get that 5x equals 160. If I divide both sides by 5, I get that x is equal to 32. Right, now I have to figure out what y equals. I notice it's also part of an isosceles triangle, so I'll use the same sort of thing. I'll have a 142 degree angle plus angle y, and then the other angle is also angle y, and those are all going to add up to equal 180 degrees. So that means 142 plus 2y's is equal to 180 degrees. If I take away 142 on both sides, I get that 2y equals 38, and so that would mean that y equals 19.